Now in this video, I'm going to describe how to find the domain of a composition of functions and why we find the domain the way that we do. So in brief, the domain of a composition of functions is the domain of the first innermost function is the domain of the overall composition of functions. So if we look at this example, it wants us to find the domain of f of g of x. So remember, we could write that as f of g of x using parentheses. So first the x gets dropped into g, and then the result gets dropped into f. So the domain of this is going to be the domain of g. Okay, the domain of g is equal to the domain of f of g of x. Now, why is that true? Well, if we think of how this is working, I'm going to draw my function machines again. Okay, so we're dropping x into g, and out comes the g of x, whatever that may be, and then we drop that into f, and out comes an f of g of x. So that's how this daisy chain of functions works. Well, you could see the way I drew it here, I drew a separate machine for g and then a separate machine for f, but really what's happening with the composition of functions, it's like all of that is the inner workings to a larger function machine that is called f of g of x. Okay, so our domain is the set of all inputs. So what's happening right there? Okay, that's our domain, and our range ends up being what comes spitting out of this machine. But the question asks for the domain. So what we need to do is figure out, well, what is the domain of g of x? Well, let me rewrite this here. So we know if g of x consists of a square root function, that inside the square root function cannot be negative. So 9 minus x squared cannot be negative. 9 minus x squared, it can be positive or 0. And another way of writing that is 9 minus x squared has to be greater than or equal to 0. That by saying that it's greater than or equal to 0, it's the same thing as saying it's positive or 0. So now if we just solve this for x, so we get negative x squared is greater than or equal to negative 9, and we can divide both sides by negative 1, so we get x squared is less than or equal to 9. So if we go ahead and solve this, we're going to find that x is between negative 3 and positive 3. So this is the domain of g of x, therefore it is the domain of f of g of x. And let's just take a moment and stop and look to see how that looks on a graph, okay? So here I have my functions already typed in here. So this is f of x right here. So there's f of x. It's a parabola. It's opening upward. It's the parent function, x squared, shifted down 9. Here is g of x. Let's see. I'm just going to rename this. Not that we need to in Desmos, but. So there is g of x. So it looks like half a circle. We could see it's starting at negative 3, 0 and ending at 3, 0. So you could see our domain of g of x from negative 3 to 3. You could see our domain of f of x is all real numbers. Now, this next function that I have typed here is f of g of x. So let's see, hold on. So now when I turn that function on, whereabouts is that function? That does not seem right to me. Hold on. Let's get rid of some of this notation. I think some of this notation is going to mess this up. There we go. That seems right. Okay. So f of g of x is this half circle that's shifted down 9. And you can see that that composition function has the same domain as g of x. It goes from -3 to 3. And you could see that on the red function goes from -3, -9 to 3, -9. Okay, so just to recap, if you want to find the domain of a composition of functions, you must find the domain of the innermost function, and that domain will be the domain of the overall composition of functions.